Welcome to LIS754, Systems Analysis and Design. And in this session, we're going to talk about integration, data, and production. When we talk about systems integration, we're talking about the process by which we put all the pieces together. And so we talked in the previous video about testing, and so certainly integration is about testing. It's about doing the systems test, being able to run all the components of this new software that we have built to make sure that everything works together. But it also means a complete end-to-end test. So what do we mean when we say that? We're really talking about involving and testing with all the external systems that we might have. And so in a system like we designed, we might use an external system for authentication. So if we're in a school or we're in a business or we're in a library, we may use that organization's authentication login and authentication system for our system. Why invent the wheel? Why make people have two logins? We may get data from a system, from another system. We may send data to another system. If you remember in our architecture session, when we developed the payroll system, we had transactions, electronic transactions that went to the bank for direct deposits for paychecks, right? We would want to test not that we just wrote the checks out to that format, to that system, but that it actually got to the banks, the appropriate banks, and that the appropriate banks were able to process that data. So an end-to-end test includes not only our system, but all the systems that our system interacts with. And there's different ways that integration can be done. I love this idea of the Big Bang theory, or the Big Bang process. We're going to just run it all right away and see how it works without doing any intermediate tests. We can go top down, so we could start at the highest level, the bottom up, start at the more detailed level. But what a lot of organizations do is something called continuous integration. So that is as they, as part of their ongoing testing for the unit testing, as part of their module testing, as part of their subsystem testing, they're always testing going to the external systems. If we remember our architecture discussion, integration is really benefits from the architecture. When we have an architecture that shows all the different systems that we're going to interact with, we have a better way of planning our integration testing, of our integration implementation. How are we going to do all this integrating? And so if we remember that this is the HathiTrust digital library, this is the digital output of the Google Books project that involved libraries. This is one of their systems, the ingest system. This takes data from Google, processes it, it sends some information to the search engine. It sends some information to an archival storage system, and then everybody tries to use this access subsystem that deals with indexing and viewing of the actual images that are from Google. And so this is 1, 2, 3, 4 separate major components that all really are their own system. And so testing this was primarily an integration project. So each of these is relatively small amounts of software, but the primary process for testing and debugging and dealing with this system is integration. Another major component it could be part of integration, but it's often thought of as its own process, is converting data from existing systems to go into new systems. So if you were upgrading a system or you were building a system to replace an existing system, making it better, making it more modern, providing more functionality, making it easier to use, you would need to get data from your old system and put it in the new system. And there's lots of ways that you can do this. This is one model of how we do data conversion, but there's some steps that, regardless of the type of process that you're using, are generalizable. And one is being able to analyze the data that you have and review it, map it to the new data model. So if you have a new system, you're going to put it in a new format. You're going to change your data model, right? You're going to add you might change your entities. You might add new attributes. You're going to test that data conversion. People want to review it and sign off on it. And then you have to go from, how do you get from your old system to the new system? This idea of doing conversions, final data conversions, so that you can go live. You can switch over from the old system to the new system. And there's a couple of ways that we can do that. One is really just a direct conversion. We are running on our old system and we just stop. At some point we just say we're no longer going to be, we're going to shut down for a weekend, we're going to shut down for some period of time, we're going to extract all the old data, we're going to convert it and put it in the new system. So no matter how you've tested it, all of that stuff is already done, but this go live process, this process of switching over from the old system to the new system is tricky. So this is one way you can do it. Just stop, take a couple of days, run the process, start up the new system. The other is this idea of a parallel conversion. We keep running our old system, but we're extracting data, we extract data from the old system. We go up, and we could run either system, the old system or the new system. This has many, many problems in that people aren't sure. You can have some people working in the old system making new data in the old way. You have people in the new system. And so eventually, at this point in the process, you're going to stop the old system, take all that final data, and convert it. What you have to do is make sure that you know which is the most current data, which is the right data. The phased conversion, we take one set of data. So let's say we've got our payroll system that we've looked at. So we may switch over and take all of the least volatile data first. So the data that doesn't change very much would be migrated first. So all of the rates, the tax rates. The next one we would do is another one that doesn't change very often, so maybe wages. The next one would be and the next one would be the time cards, right? So we could step it up. We could have a phased conversion. And the pilot conversion isn't very different from the parallel conversion. In my view, it's just a different cutoff mechanism. So data conversion is important I don't think any students are using that, are converting from old to new, but it's something that I just wanted you to have an idea that this is one of those big, this is a really big process for many, many, many systems, and systems analysts do a lot of work in this data conversion process. So at some point, we've got our system, it's been tested, we've done the unit testing and the systems testing and the integration testing, the data's conversion, and our system is live. And we often call a system that's gone live as a system that's in production. This is the term that's used throughout computer operations organizations, a production system. It's live, it's the one people use all the time. And there's a process by which systems go in this, there's this funny transition period during that first few months of its going live, where the system developers are still, and the systems analysts are all still involved, and the operations and support people are working on it. But at some point, the operations people take over running the system, and the developers go on to develop new systems. And the purpose of operations and support of an organization within a larger organization is to make sure that the system functions as it's supposed to, and that the users have access to it and can answer questions for the users, fix any problems that are going on, make sure that the system is up and running when it's supposed to. And once it's implemented, these operation support people become the face of the system and are responsible to perform maintenance activities, monitor the system, answer questions. But software doesn't stay still. Software evolves over time. If any of you has ever, has a smartphone and you it works especially on my Android phone. I see it all the time. Facebook is updated. A new version, downloading Facebook. Twitter is getting an upgrade. So my phone, I'm always getting new versions of software on my phone. And that happens because requirements change, because bugs are found, because the organization, the business, the school, the library, whoever it is, finds they have new functions they want to provide. People want new functions, they provide new functions, the software has to evolve. So this becomes a little tricky to do when you've got systems already in place. So with Facebook and those kinds of systems where it's not really transactional based. There's not a lot of, there's a lot of money, but we're not exchanging money, right? It's one thing. But when we deal with like our payroll system, or we deal with systems, it can be tricky. It can be tricky to do this. So there are costs involved with maintaining systems over time, and that has to be thought through when you're developing your new system. So when we have an existing system, it's very similar. The system evolution is not particularly different than the whole process that we have been going through, the whole systems development life cycle. This is just a process that it's an ongoing process, just like our systems development process. We have a process by which we define systems requirements. And when we did this originally, we didn't have a system to look at, but now we have a system. So if you needed to add functions to your system, you're going to analyze your existing system, define the requirements within the context of that existing system. The changes get proposed just like they were before, they get approved. Those systems get, those requirements get implemented, the system gets modified, and now you have a new system, right? You have a new version of your system that's been changed. And so this is a really important cycle that goes on in virtually every organization that has software. Let me know if you have any questions. Talk to you soon.